Hello dear students, welcome to physics classes. Today I am going to continue the solving of NEET, JEE and CET level problems from the concepts of electric charges and electric fields. The first question is, three charged particles are placed on a straight line as shown in the given figure. The figure is given here. Q1 and Q2 are fixed, but Q3 can be moved. Under the action of the forces from Q1 and Q2, Q3 is in equilibrium. Then what is the relation between Q1 and Q2? This is the question. Now let's see what are the things are given in the question. There are three charged particles are placed on the straight line. Here there are three charged particles are there. First one is Q1, second one is Q2 and third one is Q3. All the three charged particles are placed on the straight line. And Q1 and Q2 are fixed. That means the distance between the charge Q1 and Q2 is fixed. The distance between charge Q1 and Q2 is x. And it is given that but Q3 can be moved. The third charged particle, that is Q3, can be moved. That means it is not fixed. The distance of charge Q3 from Q1 and Q2 is not fixed, but it can be moved. And it is given that here, under the action of the forces from Q1 and Q2, Q3 is in equilibrium. That means this charge Q3 experiencing a force due to charge Q1 and charge Q2. Because of action of that force, the charge Q3 is in equilibrium. That means net force acting on this charge Q3 is equal to 0. The net force acting on this charge Q3 is equal to 0 means the force acting on charge Q3 due to Q1 plus the force acting on charge Q3 due to Q2, that is equal to 0. Then we have to find the relation between Q1 and Q2. In this condition, we have to find the relation between charge Q1 and Q2. Now we know that the relation, the distance between charge Q1 and Q2 is x. And the distance between charge Q2 and Q3 is x. Then the distance between charge Q1 and Q3 is here x plus x, that is 2x. The distance between charge Q1 and Q3 is 2x. Now the force acting on charge Q3 due to Q1, I am writing it as F Q3 Q1. That means force acting on charge Q3 due to Q1. By applying Coulomb's law, I can write 1 by 4 pi epsilon naught Q3 Q1 divided by the distance between charge Q1 and Q3 is 2x. Square of the distance is 2x square. Similarly, force acting on charge Q3 due to Q2, I can write F Q3 Q2. Force acting on charge Q3 due to Q2, 1 by 4 pi epsilon naught, that is Q3 into Q2 divided by the distance between them is x. Square of the distance is x square. And it is given that due to the action of forces of Q1 and Q2, the charge Q3 is in equilibrium. That means net force acting on this charge Q3 is equal to 0. That means F Q3 Q1 plus F Q3 Q2, that is equal to 0. In this condition, we have to find the relation between Q1 and Q2. We know that F Q3 Q1 is 1 by 4 pi epsilon naught Q3 Q1 divided by 2x square plus F Q3 Q2, that is 1 by 4 pi epsilon naught Q3 Q2 divided by x square is equal to 0. Now take this to the right hand side. Then I will get 1 by 4 pi epsilon naught Q3 Q1 2x whole square, that is equal to minus 1 by 4 pi epsilon naught Q3 Q2 divided by x square. Here 1 by 4 pi epsilon naught will get cancelled. Here Q3 will get cancelled. Now remaining is Q1 divided by 2 square, that is 4x square, Q1 by 4x square, that is equal to minus here Q2 divided by x square. By cross multiplication I will get here q1 into x square, q1 into x square, that is equal to minus 4 q2 into x square, and here x square also get cancelled. Then remaining is q1 is equal to minus 4 q2. So this is the relation between charge q1 and q2. q1 is equal to minus 4 q2. So the answer is option C. The next question is, 4 charges are arranged at the corners of a square as shown. It is shown in this figure. If E is the magnitude of electric field at the center due to charge Q, then the resultant electric field at the center is. The 4 options are given here. In this question, it is given that there are 4 charges are arranged at the corners of a square. In a square, there are 4 charges are arranged at the corners. The one charge is plus Q, another one is minus 2Q, another is plus Q, and another one is plus 2Q. And it is given that if E is the magnitude of electric field at the center due to charge Q. Here see, there are 2 charges of same magnitude, that is Q, and due to these 2 charges, electric field is acting at the center of this square. First, to get the center, we have to draw the diagonals. In this, we have to draw the 2 diagonals. This is the one diagonal, and this one is the another diagonal. By drawing this diagonal, these 2 diagonals intersect at a point, and that point gives the exactly the center of this square. This is the center. And now at the center, there is a electric field due to these 4 charges, and it is given that let E be the electric field, magnitude of electric field due to this charge Q. That is, from each Q charge, E is the electric field. Electric field due to charge Q is E. It is given. Then another 2 charges are there, that is plus 2Q and minus 2Q. If E is the electric field due to the charge Q, then electric field due to the charge 2Q is 2E. That will become 2E. Due to charge 2Q, electric field is 2E. Now the question is, then the resultant electric field at the center. Now we have to find the resultant electric field at the center. Now we will see the direction of electric fields due to 4 charges. Electric field due to this plus Q charge at the center is like this. This is the direction of electric field, and it is given E. It is radially outward. Similarly, electric field due to this charge at the center, this is also radially outward. Their magnitudes are same, but directions are opposite to each other, so that net electric field at the center is equal to 0. So net electric field due to these 2 charges become 0 at the center. Now we have to see net electric field due to these 2 charges, plus 2Q and minus 2Q at the center. So first we will see electric field at the center due to charge 2Q. It is positive charge, so that electric field direction is radially outward. And electric field is 2E. 2Q charge has electric field 2E. Similarly, electric field at center due to charge minus 2Q. It is a negative charge, so that its direction is towards the charge. That is also 2E. Okay, we have to take magnitude. Now we have to find the resultant electric field at the center. So due to these 2 charges, net electric field becomes 0. Due to these 2 charges, net electric field is not equal to 0 because their directions are same, so that they will add up. So net electric field or resultant electric field, that can I write E resultant is equal to 2E plus 2E, that is 4E. So that answer is 4E, option E. The third problem is, when identical point charges are placed at the corners of a square, the resultant electric field is 0 at 4 options are given. here there are 4 identical charges are placed at the corners of the square. All the 4 charges are identical in nature and they are equal in magnitude. Now we have to find the point at which the resultant electric field due to these 4 identical charges is equal to 0. We know that expression for electric field at a point due to a charge is 1 by 4 pi epsilon naught q divided by r square. Here electric field is depending on the distance. Suppose that if I take a point outside the square here and inside a square anywhere here, assume that here, and in between the sides of the square here, in all the 3 cases the distance from all the 4 charges will varies. So there is no possibility of a resultant electric field due to these 4 charges is equal to 0. Suppose that if I take a point exactly at the center of the square, then there is a possibility of a resultant electric field is equal to 0, because here at the center, if I take a point at the center of the square, then the distance from all the charges to the center is same. And here now we'll see electric field directions. Electric field due to this charge at center, that is radially outward. Let's assume that all are positive charge, then its direction is like this due to this charge. All are positive charges. Now electric field at the center due to this charge, it is like this. Now the net electric field due to these 2 charges become 0 because their directions are opposite, equal in magnitude. Similarly, due to these 2 charges, electric field due to this charge at the center, that is radially outward like this. Electric field due to this charge at the center, that is also radially outward. These are also positive charges. So that due to all the 4 charges, the resultant electric field at the center of the square becomes 0. Therefore, the answer is at the center of the square. That is option B. The 4th question is 2 point charges Q and 4Q are separated by 0.12 meter in air. The resultant electric field on charge Q is 0 at a point on the line joining the charges is. The 4 options are given. Here it is in question given that there are 2 point charges Q and 4Q are separated by a distance 0.12 meter in air. Both are positive charges. Now I am taking 2 points in air medium, point A and point B. At point A I am placing charge plus Q, and at point B I am taking charge plus 4Q, and the separation between them is 0.12 meter. Okay. Now the question is the resultant electric field on charge Q is 0 at a point on the line joining the charges is. Now I have to take one positive test charge, and that positive test charge I am placing in between 2 charges, and now I am assuming that the resultant electric field acting on this test charge is equal to 0, and now I am here going to find at what distance on this charge resultant electric field due to these 2 charges is equal to 0. Now let us take the distance from the charge which is at point A to this test charge as x. Then the distance from this test charge to the charge which is at point B becomes 0.12 minus x. Now we will see the direction of electric field on this test charge. Now first we will see electric field acting on this test charge due to the charge which is at point A, that is outward direction. This is the direction of electric field due to the charge which is at point A, because this is an positive charge, so its direction is radially outward. This is the direction of electric field. Similarly, direction of electric field due to charge which is at point B is like this. This is also radially outward. This is the direction of electric field due to charge which is at point B. Now if you observe the directions, their directions are opposite to each other, and it is given that the resultant electric field on this test charge is equal to 0. So I am writing E plus 4q, E vector plus 4q plus E vector plus q, that is equal to 0. But here the directions are opposite to each other, so that I am here taking as a minus sign. And now I am taking this minus E vector plus q to the right hand side. Then I will get E vector plus 4q is equal to E vector plus q. Now I have to take the magnitude of this one, so that like this I am taking magnitude. Now electric field acting on test charge due to the charge which is at point B, that one is E vector plus 4q, that is magnitude of E vector plus 4q. That one is 1 by 4 pi epsilon naught 4q divided by square of the distance is 0.12 minus x whole square. That is equal to the magnitude of electric field at test charge due to the charge which is at point B is the charge which is at point A, that is 1 by 4 pi epsilon naught q divided by the distance is square of the distance is x square. Now here 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled, q will get cancelled. The remaining is 4 divided by 0.12 minus x whole square, that is equal to 1 by x square. By cross multiplication I will get 4x square is equal to 0.12 minus x whole square. Now I am taking square roots on both sides, then I will get 2x is equal to 0.12 minus x. Now this x I am taking to the left hand side, this minus x I am taking to the left hand side, then I will get 3x is equal to 0.12. Therefore x is equal to 0.12 divided by 3, then I will get x is equal to 0.04 meter. Okay, now this distance, the distance 0.04 meter, I have to check whether this charge is nearer to this smaller charge or nearer to this greater charge. See here I am getting x is equal to 0.04 meter. Now this test charge is nearer to this smaller charge, so that option is the option A is the answer, that is 0.04 meter from the smaller charge and in between the charges, that is option A. The next question is the electric field in which a charged oil drop of mass 5 mg and charge 10 microcoulomb be held stationary is. The four options are given here. In a question it is given that there is a one charged oil drop. I am taking one charged oil drop and it has a charge 10 microcoulomb, that is it has a positive charge, and that charge I am taking as q is equal to plus 10 microcoulomb, that is equal to 10 into 10 to the power minus 6 coulomb. And its mass also given, that is 5 milligram. So mass of this oil drop is given, that is m is equal to 5 milligram. 5 milligram means 5 into 10 to the power minus 3 grams. Now the charge which is at rest, that means this oil drop is under rest condition. That means here one downward force is acting on it. That downward force is m into g. To keep this oil drop stationary, this downward force should be balanced by another force and its direction should be upwards, and that force acting on it due to the electric field. That force I am taking like this to keep this oil drop stationary, and that force I am writing as Q into E, because we know that E is equal to force experienced by charge, that is electric field is equal to force per unit charge. Then force is equal to E into Q. This is a force experienced by this oil drop due to the electric field. And we know that the electric field direction and electric force direction is same. So that electric field direction is like this, because electric force direction is like this. Electric field and electric force directions are always same. So under this condition, the net force acting on this oil drop is equal to 0, so that this oil drop is under stationary condition. Now we have to find the magnitude of electric field acting on this oil drop. So here I can write the upward force is equal to downward force, that is QE is equal to M into G. Now I want to find the electric field, so that E is equal to mg divided by Q. Here E is equal to, M is mass is given 5 into 10 to the power minus 3 into, now I am going to convert it into kg, so that again I am multiplying it by 10 to the power minus 3 into, this G is acceleration due to gravity, approximately I am taking it as 10 divided by Q charge is given, that is 10 into 10 to the power minus 6. Here 10 will get cancels. Here 10 to the power minus 3 into 10 to the power minus 3 minus 6 divided by 10 to the power minus 6 will get cancelled, so that E is equal to, I am getting 5. But here units are given in volt per meter. We know that in general the SI unit of electric field is Newton per Coulomb, and another unit also we are using, that is volt per meter. Here we are using 5 volt per meter, and the direction of electric field is upwards, so that answer is 5 volt per meter upwards. That is option C.